So I'm just going to take a read of the room because I'm actually curious about this. Can you just maybe let's do like a woo if we think it's the Law of Demeter. Okay, now for Law of Demeter. Okay, cool. Yeah, I have no idea. According to Wikipedia this morning, it's the Law of Demeter. I might say either, I'm sorry. So let's see how this works. Okay, so my name is Natasha Jones, or Tasha Jones, it doesn't matter. My handle is Latasha Jones. Feel free to tweet, take pictures, I don't care. I'm from Baltimore. Baltimore is awesome. Woo, Baltimore! I am also an organizer for Be More on Rails, which is our local Rails meetup group. We meet 3 Tuesdays out of every month. So if you're ever in Baltimore on a Tuesday, it's very likely that we are hanging out. You should come hang out with us. I'm also an engineer at Fractured Atlas. Fractured Atlas is a nonprofit tech company based out of New York, but our engineering team is 100% distributed. So we're writing apps to support artists in the work they do every day, and it's awesome. Okay. So my talk is called Breaking the Law of Demeter, or Demeter. In preparing for this talk, I was really amazed and slightly overwhelmed by just the massive number of resources out there about the Law of Demeter. It became really popular, I think in there's a year, 2011 or something, like Ruby Rogues, it was mentioned on Ruby Rogues multiple times, and then everybody was blogging and talking about it, right? So I got a little overwhelmed, and those resources were really helpful, but the thing they were most helpful for me was that they pointed me to the source. So it actually comes from a paper, an academic paper. This paper was written in 1988 at Northeastern University, which I think is in Boston. So this talk is an interpretive talk based on what I think, not coming from a computer science background, is a kind of dense computer science paper that very importantly never once mentions dots. And I'll touch on that at the end to why that's important. So this law has 2 primary purposes. The first is that it simplifies modification to your code base. And we have to remember, right? We think that we build a thing and it's finished, and that's just not the case ever. So we want to write code that's changeable, so it simplifies modification to our code base. The other thing it does is it simplifies the complexity of programming. And I'll touch on these more as we go through the talk. So this law was sort of established, or this paper was published, rather, in 1988. Since then, there's been a lot of discussion of what good code looks like. What are good practices for writing code? And you'll find that a lot of the ideas in this paper sort of bled out into all of the ideas that came after. So these might seem familiar. Some of the things that work hand in hand with the Law of Demeter are controlling coupling, right? Information hiding. Oh, come on, little guy. What are you doing? Okay, well. Localization of information, narrow interfaces. So that's just some of the things that you may hear about, as an engineer any given day. So this is the definition of the Law of Demeter from the paper itself. I had it up earlier. I personally find it just not legible. I'm sorry. I've read the paper probably tens of times, and I really struggle to read through this and glean much from it, because they're trying to explain something kind of complicated in a short, concise way. There's also this English language description, which I can't find an actual source of. You find it in WikiWiki, Obdigrim cites it, and it goes something like this. And don't think that you have to remember all of this or write it down. So first, your method can call other methods in its class directly. Your method can call methods on its own fields directly, but not on the fields. When your method takes parameters, your method can call methods on those parameters directly. When your method creates local objects, then that method can call methods on the local objects. Okay, so I actually don't find that super helpful either. The coolest thing about this paper, though, it has these pretty solid code samples, And one of those code samples revolves around the idea of a library. So this is Enoch Pratt Free Library. It's gorgeous. So again, if you're in Baltimore, come to Be More on Rails. And then the following day, you can go check out Enoch Pratt Free Library, look at the frescoes on the ceiling. And Enoch Pratt Free Library, like any library, has a lot of sections. We're going to look at 2 sections of the library. The first section are the stacks. And so I forgot to mention, I'm going to mention quickly, that all the code in this paper is written in this typed pseudo Lisp. So I've actually transcribed all of that into Ruby, since this is a Ruby conference or a Rails conference. So any faults in the code are my own and not the authors of the paper by any means. So we have a class called library. And library has 2 dependencies. It has the stacks and the archives, right? I'm sure we all remember this from college or just going to the library. And so let's go ahead and write out those 2 dependencies. The stacks has a dependency called books. We have a bunch of books, right? And the archives has 2 dependencies, microfilm and documents. And microfilm is just sort of like photographed documents that you can look at in this like awkward giant machine. And so we can just write those out very quickly and simply. We don't need to like implement them fully for this example. This is what it looks like. It's a chunk of code that we're not going to remember, but this helped me a lot. When I was working on the paper, or working through the paper, I ended up doing a lot of like sort of sketching out and trying to like gnaw on what I was reading. So at the high level, we have a library, and that library has 2 sets of dependencies. It has the stacks and the archives. The stacks depend on books. The archives have 2 dependencies, docs and microfilm. You all got that, right? Yeah, okay. So let's say that we want to add a method to our library that allows us to search through the whole library. So we just pass in like a string query, and we can search through it, and we'll return whatever, the object from the library, the thing that we're looking for. So we can implement it maybe something like this, right? We have this library search method on library, and it kind of looks through the dependencies of library and figures out what to return. So the first thing is it like sort of looks through the stacks. So we'll implement a search method on stacks, like say that's done and that works. And if nothing's returned from the stacks, we'll call arcmicrofilm.search. So arcmicrofilm is, what is that, right? Like now we know we want to search all parts of the archive. So we have to think like, what is arcmicrofilm? And we look at it, it's an instance variable. It's also a class, another class, a third class. So we're going to go into our third class microfilm. We'll add our search method. All right, okay, that's done. Now okay, what is arcdocs, right? That's the last part of this statement. Same, it's an instance method. It's a class. So we'll add our search method to arcdocs. This is breaking the law of Demeter, or Demeter. The fact that we're reaching from archive through into a third class, calling a method on that third class, that's what's breaking the law. So the best way to describe this, or a thing I'm going to use for describing how awkward this is my grandma, a person. This is my grandma, Betty. She lives in California. We're really close despite the distance. I live in Maryland. I've always lived in Maryland. And every time I get to see her, it's kind of a big deal. Like, I'm really excited, right? I get to see my grandma, and she always says the same thing. She says, oh, well, hello there. She's really excited, right? And then the second thing she always does is she asks, how is Ali doing? And Ali is my partner. So what you're doing when you're breaking the law of Demeter is similar to this, right? Well, I'll go get him for you. And that's really awkward for my grandma because he's in Maryland. Right? But like, I need Ali there so that he can answer her question, right? He has to be there. But what she really wanted was for this to happen, right? She wanted for me to be able to say, I know that Ali is doing great, right? And I should be able to do that. We shouldn't depend on Ali's presence to have a conversation. That would be a total bummer. So let's look at this code. And my favorite approach to refactoring, and I think people hear it a lot, is to write the code that you want to see right? Write the code you want to read. So I'm going to do that. I want it to read this way. I want it to only point at the dependencies of this class. So I'm going to do archive.search. And that's awesome, because we've just done two really cool things. We've controlled coupling, and we've done information hiding. And we're not breaking the law of Demeter anymore. That's really fantastic. So these things all go hand in hand. And then we can implement that method, def-search, in archive. And now archive is the only thing that knows about its own dependencies. So let's look at another example of this. We'll look at TheStacks, right? The other part of our domain. Now, TheStacks is like a little less complicated. It's only sort of like the library, TheStacks, and books, as opposed to having these like dual dependencies down under archive. But this is doing a really similar thing to what we saw before. We're calling the stacks.books, and we're sort of looping through them to get back the desired book, right? What is books, though? I mean, first of all, books is an instance variable of a dependency, right? Which is kind of a little sketch already. Second, books is another class. It represents a third class. So we're basically embedding that dependency into library. So we can do better. So we could do something like this. The stacks.retrieve, fine. And now we can tuck all that logic into this retrieve method. That looping can happen. Even the knowledge that the stacks has this array of dependencies, all of that is tucked into our stacks class. And where this really shines is when we want to do something like maybe they decide to add ebooks to our library, right? So we didn't have to touch library to make this change. Because library, when it calls the stacks.retrieve, it just expects the message it expects, right? It just expects that to work. And now the stacks can handle what that actually means, what the message that's sent is. And in this case, we're adding ebooks to our stacks. So interpretation. So we've seen a couple interpretations of this law already. The first one was the one in the paper, right? The sort of like definition. And the second one is the English language interpretation. And enforcement. So like all laws, the Law of Demeter is subject to unequal, unfair enforcement. And the example of that is it has two main types. We have the strong Law of Demeter, which posits that when you have a class that inherits from another class, right? So you have class A, and class B inherits from that class. Class B is allowed to use the instance variables from class A. The weak law of Demeter, oh no, sorry, that's the weak law. So the strong law states that class B cannot use instance variables from class A. The weak law states that class B can use those instance variables. So let's look at an example of that. And like all engineers at Northeast University in 1988, we're going to use an example of a fruit basket. So, of course, fruit basket. That's what I would have thought of first, too. So let's go ahead and build our fruit basket domain. So we have a fruit basket, and that fruit basket has a dependencies called fruits. The fruits has dependencies. We have apples and oranges. And then apples and oranges have a lot of shared behavior, so we can abstract that out into a fruit class. So both apple and orange inherit from fruit. And this is really important because this is the crux of the strong versus weak law of Demeter. And so this is what our domain looks like overall. So let's say, for example, that we want to add, and don't look at that too closely, it's, but let's say, for example, that we want to add the functionality to figure out what the weight of the fruit is when there's no packaging on it. All the packaging's been removed. We might do something like add a method to fruit basket that calls a method on fruits that loops through all of the fruits to figure this out. An important thing is our apple and orange have divergent behaviors, right? They have different packaging weights or whatever. So here you can see we've defined those methods here. We have weight before packaging and on both of them. And they both use this at weight instance variable. So this is a perfect example of the weak law of Demeter. So this is not technically breaking the law of Demeter, right? Unless you're adhering to the strong law of Demeter. This is what it looks like under the strong law of Demeter. So you can see that we sort of wrapped that weight instance variable with a method, this like sort of method that we can get it with in fruit. And we're using that method in the classes that inherit from it instead of calling the instance variable directly. So the advantage of that is not super clear. In fact, it kind of looks like it just leads to this proliferation of methods in your code base, right? Which kind of sucks. But this is from the paper. Of course, many years have passed since we wrote that code, and now mankind no longer finds itself bound to Earth. He has the ability to take fruit baskets to any number of different planets around the galaxy. Yeah, all right. It's 1988, they're really excited about space. I'm glad they were. So now we have intergalactic fruit. This introduces another dependency, right? I mean, it introduces a lot of complexity. And I'm going to warn you, what comes after this is not accurate of physics at all. But we introduce another dependency, and that's the planet, and like sort of the gravitational pull and weight of the planet, right? So let's introduce that dependency. Here we have it. We add it as an instance variable to our fruit class. And you'll see, this is under the weak law of Demeter. We've had to go into apple and orange to adjust our wait before package method, right? We've had to go into 3 classes because this single dependency was added to one class. That's a red flag. When in fact, if we were using the strong law of Demeter, right? So here if you look at the get weight method where we were wrapping that weight instance variable, now we only change it in one place. This is great. This is like way easier. So back to sort of the reasons we should be thinking about and using the law of Demeter. First, it simplifies modifications. So we kind of looked at that in library. Another example of this in library is like, let's say for example, like again, it's 1988. The archivists are wanting to like really catch up with the times, you know? And they decide they're gonna digitize everything to CD-ROM because that's just like cutting edge technology. So if they need to do that, with this logic, with these dependencies sort of being spelled out in library, they're gonna have to go and change library and archive, both classes. And if a code base is written this way, they're probably gonna have to go in more than 2 classes to make that change. But the solution we had before where we wrapped everything and everything was contained in archive allowed us to only make that change in archive itself. So the other thing it does is it simplifies the complexity of programming. When I read this, sort of on first read, I fully expected the next paragraphs after that to sort of explain, you know, in-depth technical detail of how it does this and proving that it does this, and the paper doesn't do that at all. In fact, it basically just said, yo, it's more fun and easier to program when you do this, when you use the law. We've decided that as a team. And when you think about it, it really is the case because it reduces the cognitive load of your work, right? So when you're sitting there editing a particular class, you don't have to be thinking about all the places that this sort of class has leaked into as a dependency because you have some understanding of the fact that that class as a dependency has been contained. So again, I mentioned before, I work at Fractured Atlas. We're a nonprofit tech company that helps artists build, or we help artists by building software to help them manage their the business side of being an artist. So one group that we help in particular are small theaters, right, like community theaters. So let's go ahead and look at what like the law of Demeter looks like in the context of Rails. So let's say we have a director, and a director has many plays. And the play belongs to the director, and the play also has a playbill, and a playbill belongs to a play. So notice that there's no direct connection between play and director here, right? Playbill is sort of always an intermediary. Let's say that we want the playbill to be able to display the director's name. We could do something like this, play.director.name. Now this is breaking the law, right? So you have your play, and you're reaching through play to get to this third dependency, right, which is not a dependency of playbill, to call name on that. So this actually becomes a hidden dependency. I think that came up in one of the talks earlier, and it really struck me that this is one of the things that can make your day really painful, right? Like this is a simple example, but these hidden dependencies can cause a lot of trouble. So it gets even worse, of course, because we're working in Rails, and so everything ends up with a nil check, especially strings. So this is a disaster. Oh my God, we've got to do better than this. So what if we wrote a method on play called director name? That should end the breaking the law of Demeter, right? We're just going directly to the dependency, and we're writing a method. What this has done two really cool things. The first is that it's contained the knowledge of director, right? So now the only thing that knows about director's behavior is play. And director is already a dependency of play. It's also contained the knowledge about whether or not a director is mandatory. Like, can it be nil, right? So now play knows director could be nil, but playbill doesn't have to know that. So there's a way to do this in Rails, a really interesting tool. I have some mixed feelings about it. I'm happy to talk about that after. There's a method called delegate that will automate a lot of this for you and sort of create those accessor methods for you. So we can call delegate name to director in play, and then that will let us call something along the lines of play.name, which will return a name, cat power, she's rad. But this is super confusing. I mean, like play.name, that should be the name of the play, right? Not the name of the director. Okay, so they have a solution to that. You pass in prefix true, and then what you get is something like this, right? Your method, the method that this delegate tool meta-programs for you is now called director name. Way more clear, much better. Patty Smith, she's rad. Yes, it works. This is fantastic. There's only one problem. What if she's not around? Then we're like really screwed. So there's a solution to this too, of course. Whatever. So there's a tool, and I'm including it because it is that. It's a tool, and you can use it with discretion. I think it takes away a lot of the flexibility of just writing in your own director name method. Thank you, Vaidehi. We've talked about interpretations, right? Well, the Ruby community has this really interesting interpretation, and it may not just be in the Ruby community, but it comes from a little bit of confusion, and it's a language confusion. So you'll frequently hear when you talk about the law of Demeter in Ruby, oh, that's the law of one dot, right? It's like, no, it's really not. So what happens is, in the paper, the language, like I mentioned, is a typed pseudoscript. So the paper goes into great deal about the class types that your functions are returning, right? So let's look at the example of chaining methods that does not break the law of Demeter, and talk for a second about why it doesn't break the law of Demeter. So let's say, for example, it's April 1st, and we just, for some reason, think it'd be hilarious to reverse all the names in the playbill, I guess. I don't know. People come up with ideas. So we're calling play.directorName, and we know that returns a string, right? Now, what is the dependency? This is kind of a trick question. Shout it out if you know the answer. What is a dependency of every single thing written in Ruby? Yeah. Let's go like a little higher level. Ruby. Yes, all those things, but Ruby. So string, it's play.director is returning, so we already know that that's not breaking the law of Demeter. Play.director is returning a string, and string class is a part of the Ruby core. And then we're calling the method .reverse on that. And .reverse is a method in the string class. String is a direct dependency of playbill, because anything written in Ruby is dependent on Ruby. And we're calling a method on a direct dependency. On top of that, we're retaining the same type, right? Our class has not changed. The class of play.directorName is the same as play.directorName.reverse, right? It returns a string. And then when we call upcase, again, it returns a string. So that's really fantastic. We're not breaking the law. It's great. So I hope that this has given you some tools to enjoy your, laying around in your bed, hacking on your little tiny computer. I hope your computers are bigger than this. I'm really grateful. I have to just give some credit. Ali Ibrahim, my partner, is here, and he's fantastic. And he helped me sort of sift through some of the pseudo lists. I don't have a CS background, so that was really great. My grandmother, she doesn't know that she's in this. Vaidehi Joshi, of course, lent her amazing modeling skills. Jamie Gaskins, Nick Evans are amazing members of the Be More on Rails community, and you can meet them if you come to one of our Tuesday meetups. And there's a bunch of fantastic resources, so I hope you've all enjoyed this, and thank you for taking the time. Yeah.